so now we're just going to practice doing what we just learned. So the biggest thing is read the problems carefully. Know when you're looking for a probability. Know when you're looking for a count. Alright, know when you have independent events, when you don't have independent events, when you're allowed repeats, when you're not allowed repeats. Alright, so the first example, suppose you play two unrelated games, one after the other. There's a 35% chance, so again, unrelated means they're independent events. It actually says that they're twice. Probability as a percent. Alright, so reading the problem carefully. There's a 35% chance of winning the first game, 40% chance of winning the second game. Use the product formula for independent events. Find the probability you win both games. Give it as a percent. Alright, so probability you win the first and win the second. Remember, is the probability of the first times the probability of the second, but these have to be decimals. So the probability of winning the first was the decimal, 0.35, times the probability of winning the second, which was the decimal, 0.40. Comes out to 0.14, but then we want to write it back as a percent, so 14% chance that they're going to win both of those. Alright, the following refers to the choice of two cards. And so I tried to word these like the book does, or the web assignment, because the web assignment sometimes words things a little differently. Alright, so the following exercise refers to choosing two cards from a thoroughly shuffled deck, meaning every card is randomly put in the deck. You do not put the first card back in the deck before you draw the next. So, no repeats. That's important. What's the probability? The first card is a club and the second one is black. Give the probability as a fraction. Alright, so probability. The first is a club and the second is black. Now, you can't find the probability of both of them. They're not independent because the club is a black card. If you go look at your, up here, clubs are also black. So these are dependent events. So you have to take into account the first event occurred before the second event. Alright, so yeah, remember half the deck is black. Clubs are also black. So first thing you're doing is you're picking a club. You're not repeating. So the probability to pick a club, well, there are 13 clubs out of 52. And means you do multiply, but because you're not repeating, there's a club already sitting outside of the deck. Alright, so there's, again, we've taken a card away, which means there's only 51 cards left. A club is also black, so we've also removed a black card. So there are no longer 26 black cards, there are only 25. So you've got to keep that in mind. So again, this is where they're dependent and you have to subtract. Alright, then leave the probability as a fraction. When they ask you to do this in WebAssign, you leave it as the reduced fraction. Every single scientific calculator out there has a fraction key. So you just multiply it out and then hit your fraction key. If you do, it will give you the reduced fraction. In this case, the reduced fraction is 25 out of 204. Alright, and that would be the answer you would give in WebAssign. Alright, I am volunteering at the state election. There are 6 candidates for governor, 4 candidates for lieutenant governor, 3 candidates for the House of Representatives, and 4 candidates for the Senate. Alright, so I've got governor, lieutenant governor, House of Representatives, and Senate. How many different ways can I fill out a ballot if I vote once for each? So suppose I don't know who to vote for. I'm just going to randomly vote for people. Alright, I have to pick one of each of those. So I have to pick and vote for a governor and a lieutenant governor and a House of Representatives and a senator. Make sure I got them all. Governor, lieutenant governor, House of Representatives, and a senator. I have to do all of those, right? It's and this is not asking you for a probability, this is asking you for a count. So this is just the event. If I randomly fill out my ballot, how many different random ways can I do that? Alright, so how many? Well, for the governor, there were 6 options. For the lieutenant governor, there were 4 options. For the House, 3. And for the Senate, 4. And since I used the word and, I'm going to multiply. 6 times 4 times 3 times 4. And so there is a total of 288 ways to fill out if you do it randomly. Alright, there are 288 ways to fill out a ballot if I do it randomly. The following refers to the choice between two cards. Alright, so we're picking cards again. Assume the deck is shuffled and you return it. Alright, so you are allowed repeats. Alright, if you put the first card... So again, they've actually told you this twice. I'm kind of giving you the different ways the book can do it. So again, assume that the card is returned. You put the first card back before you draw the second card. What's the probability? So I'm looking for probability, which means I need my event divided by my total. So I'm going to have to figure out two things. I'm going to figure out how many and the total. Alright. So sometimes it's easier to split it up, but we'll see how it goes. Alright, so if you want the first card, give the probability as a fraction. The first card is a 6, and the second card is a queen. Alright, so this one I'm just going to do together. So probability of the first is a 6, and the second is a queen. We replace it, which means every single time we draw a card, there's 52 of them. So there are 4 6s. You go look at your deck. There's 4 6s, and there are 4 queens. And so these probabilities are actually the same. There's 4 out of 52 cards for the 6s, and there's 4 out of 52 cards for the queen. So it's just 4 out of 52 for the first, and 4 out of 52 for the second. Write it as a fraction, so multiply it out first. Then hit the fraction key on your calculator. If you do, it comes out to 1 out of 169, if that's how I ask you for it, as an answer. Alright, the following exercise refers to the tossing of a pair of dice, alright, which we did this earlier in the chapter. What's the probability of the total number of dots? So this is somewhat, I was kind of alluding to this before, this is a sum. It's just a weird way for them to say sum. The total number of dots appearing on the top is 4. So they're adding them up, and so that means the sum is 4. Right, total number of dots is 4. When you add up the dots, you have 4 of them. So that would be like if you had 3 dots and a 1 dot, right? Total sum is 4. Right, sum is 4. Give the probability as a fraction. Alright, so we're looking for probability. Right, you get a sum of 4. It's just a weird way that the book puts a sum of 4. So so you do have this, remember you have this set, there's the rolling the dice, we want a sum of 4, so the sum of 4, sums always go diagonal, and so you look at the dots and how many ways the dots are going to add up to 4, those are the 3 ways out of the total. Remember there's a total of 36 outcomes when you roll a dice, pair of dice, 3 of them have a sum of 4, a 1 and a 3, a 2 and a 2, and a 3 and a 1, so we get 3 out of 36, and you always write the answer as the reduced fraction. So if they're asking you for the fraction, don't give 3 out of 36, give the reduced fraction 1 out of 12. Alright, a room has 3 light bulbs, each with a 20% chance of burning out within the month. Alright, what's the probability as a percentage? I've got to write the probability as a percentage, rounded to 1 decimal place. What's the probability that all 3 will be lit at the end of the month? All right, and they're independent events. These are independent events, right? That's what each one has a 20% probability of burning out. With whether one burns out or the other, one burning out should not have the effect on the other burning out, right? There should be independent light bulbs. So, what the weird part about this question is what they ask you. Probability that it will burn out is 0.2. So the probability that it will be lit means it won't burn out would be 1 minus that 0.2. So probability that it's lit is 0.8. 80% chance that it's still lit up at the end of the month. Alright, so again, you kind of have to pay attention to the wording. They are independent events, so it's just the probability that the first will still be lit And the second will still be lit, and the third will still be lit. Well, the chance of each one of those still being lit is 80%. So it's just 0.8 times 0.8 times 0.8, which comes out to be 0.512, which is not the answer. Again, read the problem carefully. The probability as a percent rounded to one decimal place. So that's the decimal. The percent would be 51.2% rounded to one decimal place. So make sure you're careful on what they're asking for. All right, the next example. Suppose we have an opaque jar that contains 5 red, 10 green. The following X refers to picking 2 without replacement. All right, so keeping that in mind, we're not replacing our marble. There's a total of 15. All right, total of 15. All right. What's the probability? So we're looking for probability of getting a green marble and a red marble. Keeping in mind, we're not replacing, write it as a fraction at the end. All right, now, we have 2 picks. It didn't say which one. You didn't say we picked red first and then green second. So there's 2 actual outcomes. You can pick red first and green second, or you can pick green first and red second. All right, so there's 2 possibilities. And we multiply or we add. So the probability of picking red first, well, we have 10 red marbles out of 15. Then we're going to pick a green marble. But remember, I pulled the red marble out and I didn't put it back. So there's no longer 15 marbles in there. There's only 14. There's still all the green ones left, though, because I only pulled a red marble. So I still have, and I did that backwards. It should have been 5 red, right? 5 red out of 15. I pulled one of the red marbles out. There's 14 left over. But I pulled a red marble out, which means the greens are still all there. So there's still 10 green marbles left and 4 red marbles left. So 14. So it's 10 out of 14 for the green. All right, so that's the first outcome. Or, remember the word or, we use a plus, we add. The opposite's happening. So first thing I do is pull out a green marble. Well, there are 10 green out of 15. And then the seconds are red. So remember, I pulled a green one out. So there's only 9 greens left. I still have 5 reds. So it's still 5 reds, but it's no longer out of 15. There are now only 14 marbles left because I pulled one of the green marbles out. All right, and then we multiply that out. Just make sure you're careful. I just multiply it straight out and then use my fraction key since it's asked for a fraction. So I take 5 times 15, 5 over 15 times 10 over 14 plus 10 over 15 times 5 over 14. And where I have parentheses, I tend to put parentheses as well. And then you hit your fraction key and it should come out 10 over 21 possible outcomes. Alright, so the following example, we're going to toss a pair of dice. So we're going to do our pair of dice again. What's the probability the sum of dice is not 10? And your probability is a fraction or rounded 2 decimal places. Alright. So the sum of the dice is not 10. So we want the probability that the sum is not 10. Well, the easiest way to do that is 1 minus the probability you get the sum of 10, right? Because the sum of not 10, which would mean you have a sum of 2, or 3, or 4, or 5, or 6, or 7, or 8, 9, skip 10, 11, or 12. So the easiest way is to figure out the sum of 10 and subtract it from 1. So out of 36 outcomes, how many ways do we get a sum of 10? So I go here, so there's my 36 outcomes, a sum of 10 would be those, right? 6 plus 4 is 10, 5 and 5 is 10, and 4 and 6 is 10. So there are 3 outcomes. So 3 out of 36. But we're throwing those out. And so we take 1 minus 3 over 36, which is going to give me 11 out of 12, right? There should be 33 that are not a sum of 10. So 11 out of 12, but it said fraction and then a decimal. There's my fraction, so now I'll give my decimal rounded 2 places, so 0.92. Ah, shoot. All right, here's our light bulb example again. Room has 3 light bulbs. The probability of one being burnt out is 20%. Find the probability as a percentage rounded to 1 decimal place. So again, remember the final answer I need it as a percentage rounded to 1 decimal place. Find the probability in the month at least one of them are lit. Alright, so probability at least one is lit. Lit meaning it's not burned out. Remember, it'd be 1 or 2 or 3 or everything in between. And so the easiest way to do that is 1 minus the probability. None of them are lit, so it means all 3 burn out. So the first burns out and the second and the third. So remember, when we do that, it's a straight multiplication, but you change your percent to a decimal. So the probability the first burns out, 0.2, and the second burns out, 0.2, and the third burns out, 0.2. So the probability that they burn out is 0.2 times 0.2 times 0.2, which is not your answer. All right, that's just the chance that all 3 of them burn out, which is 0.008. So the probability that all 3 light bulbs burn out by the end of the month is 0.008. That's the one we're going to get rid of, so you take 1 minus that, and so the chance that at least one of them will still be lit is a pretty high chance, 9.992. But remember, that's not the answer. That's not what you plug into your, if that's what they're asking for. Remember, the answer is write it as a percentage rounded to 1 decimal place. So the answer would be 99.2% chance at least one of the 3 light bulbs will still be lit at the end of the month. Alright, the last one. Jim owns 10 shirts, 3 ties, 4 pants, 2 belts, and 8 pairs of socks. An outfit consists of a shirt, tie, pants, belt. So basically one of each. Shirt, tie, belt, pants, pair of socks. How many different? So how many? We're not looking for probability, just want the count. Different outfits can he select for his wardrobe? Alright, so this is just, he has to pick 1 shirt, and I don't need the 1. He needs to pick a shirt, pick a tie, and pants, and a belt, and socks. You can read that. So, shirt, tie, pants, belt, socks. So again, you're just going to multiply all the things he has to select. So make sure I get them all. 1, 2, 3, 4, 5. Alright, each shirt. So when he picks a shirt, he has 10 outcomes for that. When he picks a tie, there were 3 outcomes for that. Pair of pants, there were 4 outcomes for that. Belts, 2. Pairs of socks, 8. So it's going to be 10 times 3 times 4 times 2 times 8. And that means he has a grand total of 1,920 different outfits. Again, if we're saying that each one of those is different. Alright, that finishes up practicing probability. Alright, we're going to do more counting in the next section, which is going to be our tougher section. I'll stop there.